Today's concept is going to be very interesting, right? So here we all know that when we roll a single fair dice, then the possibility of, or maybe we can say that all possible outcomes will be this, and set of all possible outcome is known as sample space. This is what we have learned so far, so we are just trying to recap that. And any subset of this sample space is known as an event. So there could be any subset of the sample space. For example, let's consider about a subset of even number, or maybe event of even number. So what could be all those possible numbers? So those are these, right? So here we got all those even numbers. Then another subset which we can think, or we can say that event of having a number less than 3. So all the possible values which we can see are these two. These are the only two values which are less than 3, right? So this is the event of having a value less than 3. Now if you have to find the probability, let's give this event name A. Then the probability of having A, which is having a even number, will be equals to all favorable outcome, number of all favorable outcome divided by all possible outcomes. So there were 3 favorable outcomes and all possible outcomes were 6 for getting a even number. So when you solve this, you get 0.5, and when you solve, if you want, you can say this as 50% as well. So when you roll a single fair dice, then probability of getting a even number will be 50%, right? Now then think of this event. Let's name this event as B. Probability of having B, that means a number less than 3, will be equals to number of all favorable outcomes, which were 2, divided by number of all possible outcomes, which were 6, and when you solve this, you get 0.3 or 30%. This was the recap of whatever we had learned previously. Now let's keep them all aside and think of a situation of getting an even number and that should be less than 3 at the same time. Now look at these two subsets, this one and this one, these two events. The number which justifies to both of these two conditions will be this, that is 2. This is something which is even and at the same time it is less than 3. So if you put the event name A and event name B, and then the question comes, what we gonna say this particular thing? So this is represented by inverse U, which is known as intersection. So in terms of mathematical representation, we're gonna say what is the probability of getting A intersection B. So there is only one possible outcome, or maybe favorable outcome, I would rather say. So probability of getting A intersection B will be equals to probability of A into probability of B, and when you impute the real number, then from here we can see that probability of A is 3 by 6 and probability of B is 2 by 6, right? So the number which we get is 6 by 36, to which if you further solve, you get 1 by 6, and this is solved to 0.16. So this is called the AND event. I just hope that it was clear. So in AND event, all that we try to find is intersection of 2 or more given events. So here the first event which we had was having even number, probability of having even number, and the second one was having a number less than 3. So wherever it intersects, that was the probability of A intersection B. Now let's have a look on this one. Here we have again these two sets, event of even number and event of a number less than 3. Let's see event of even number. So these are all the numbers which justifies to this thing, or event of less than 3, or event of both of these two, right? So the yellow marked are something which is justifying both of these two. So we're gonna figure out a set where either we would have a even number, or we would have a number which is less than 3, or we would have a number which justifies to both of these two things, right? So in this set we require to have all those possible numbers. Remember, in the previous example we were trying to find one single, only intersecting number, and here we are trying to find all the numbers from both of these set except duplicates. Okay, so let's name this A and name this B. Then what we gonna call OR? So that is represented by U. So we're gonna say 8 in terms of formula. We're gonna say what is the probability of A union B. This is called union. Now let's try to understand it over here. So probability of A union B can be found like this. Let's have all the favorable outcomes for probability of A, right? And then let's have the same for probability of B, and let's combine both of these two. Before that, of course, we need to figure out what are the duplicate values. So these are the duplicate values. So we're gonna combine both of these two sets in a way that duplicates values are removed, and then the unique numbers which we get, that's the favorable outcome for getting probability of A union probability of B. Probability of A union B. So the favorable outcome are 4. Let's try to put this in form of mathematics. So here we're gonna say probability of A union B equals to probability of A plus probability of B minus probability of A intersection B. You remember in the previous example we calculated A probability of A intersection B. So how are we gonna put it over here? Here this will come over here, probability of A plus probability of B, which is this, and that comes over here, minus probability of A intersection B. We got 1 by 6. Now when you solve this you get 4 by 6, and when you further solve this you get 0.66. So this kind of calculation or finding this type of probability is called OR probability. Okay, sorry, OR event. This kind of event or probability calculation is called the OR event, where we are simply trying to find possibility or probability of having a number out of either of these two sets, or a number which is common in both of these two sets. Let's try to repeat or revise all these things which we learned. So this is the sample space, and this is a subset of sample space which is for even number. This is the subset of sample space which is for a number which is less than 3. Now if you try to find probability of A intersection B, let's say this is the set A, this is the set B, this makes set B and this makes set A, for example this, and then set B is this. Then in A intersection B, what we are trying to find is this area. All right, in whatever number falls in this area, that's something which we are trying to find. On the flip side, when we talk about A union B, probability of having A union B, that will be set of A, set of B, and we're gonna combine them all together, find the duplicate values, remove that, and whatever we are left with, that's the favorable number of outcomes, right? So if you see in first case over here, in case of AND, then there is just one favorable outcome, while at the flip side over here we have 4 favorable outcomes. Now when you put in terms of formula, then probability of A intersection B equals to probability of A into probability of B, and when you put in form of numbers, then 3 by 6 into 2 by 6, which will be equals to this, and then further it is solved to 0.16. Now let's have a look on the second one, where we are trying to find probability of A union B. Now in this, if you find probability of A union B, the formula is probability of having A plus probability of having B minus probability of having A intersection B. So whatever is common between both, we're gonna keep that, but removing the duplicates. Okay, let's put it this way over here: 3 by 6 plus 2 by 6 minus 1 by 6, and when we solve this, this is what we get, which is 4 by 6, and then it is finally solved to this number, which is 0.66, or you can say 66%. So this is the comparison between and or event, or maybe we can also say intersection and union event. All right, so I just hope that it was clear to you. All that you should note is this formula which I just highlighted. Thank you very much for watching the video. I just hope that you liked it. If so, just give a thumbs up and do not forget to share it with your friends. Thank you very much once again. Wish you very all the best.